So we're going to be finding the magnitude of 3D vectors. Hopefully if you're looking at 3D vectors, you should be familiar with 2D vectors. We're going to do a recap, show you how you find the magnitude of 2D vectors, and then we'll do an example on the right of when we use 3D vectors. What's the same, what changes? Okay, first of all, we should be happy with what we mean by a magnitude. Now, any kind of vector always has a size and a direction. Your direction is normally given by an angle, and your size is just a whole number, okay? It's just going to be a number and a angle. So that number, that size, is also called a magnitude. It's another word for the same thing. Okay, so we're looking at the size of an angle, the size of a vector. So first of all, we'll do it in 2D. Hopefully this is a recap, if anything. Let's have a look at the notation as we go. So I'm going to call a vector A. Okay, remember I underline it because I can't write it in bold. This vector, I'm going to write as a column vector like this. It's going to be 6, 3. Okay, and what we're going to be finding is the magnitude of that vector. So we're going to find the magnitude of A. Okay, so I'm going to draw this on a set of axes just to, because it will become clearer when I look at a 3D vector as well. Let's have it, our y-axis going something like this, and our x-axis going something like this. Okay, so I'm going to draw it like a position vector, effectively. So we're going to go from the origin, we're going to go 6 along, so something like that, and 3 up, something like that. So we end up here. This is the vector we have done. Okay, it's just a sketch, not to scale, and we're going to call this vector A. Okay, so when we created A, we had to follow these instructions. We had to go along 6, so to here, which is 6, to the right because it's positive, and then we had to go up 3. Okay, and it's up again because it's positive. If it was negative, it would be down. And you can see here that whenever we draw out this vector, we're always going to end up with 2 values that are perpendicular to each other. So we end up with a right angled triangle, and our magnitude, the size of this vector, is going to be the length of this line. Okay, so the length of this line is the magnitude of A. Hopefully now you can see we've got a right angled triangle. We're looking for the hypotenuse. We have the other 2 sides, so we are going to do Pythagoras. So let's write it out. We've got the magnitude of vector A is going to be equal to, well, you've got this side squared, so that's 6 squared, plus this side squared, 3 squared, all square rooted. Okay, don't forget if you're typing it into a calculator, it can be good practice to put brackets around the things you're squaring, just in case they're negative, then you know that when it squares it, the answer is going to be positive. It will follow BIDMAS, your calculator will. Okay, so let's work this out. You've got 6 squared is 6. 9, square root that, and we get square root of 45. 45 is 9 times 5, so it's going to be 3 root 5. And that is the magnitude of this vector A. Cool. So I'm going to split this page in half, and we're going to look at the magnitude of a 3D vector. Let's have a look, see what changes, what stays the same. We'll start out with a very similar problem. Let's have our 3D side here, and we're going to have a vector A, and this time it's going to be 6 to the right, 4 down, and then 3 kind of coming towards you or away from you. It depends on what we're going to take as positive. Let's say into the pages 3. Okay, this is our vector. Remember, this is our x, y, and z. And we're going to find the magnitude of A. Okay, I'm going to draw a sketch on a graph, and you'll see that when you're doing this on a graph, it's very tricky to kind of add that 3rd dimension onto a graph. So as long as you understand what's going on, you can skip straight to the kind of application, sticking into the calculations rather than drawing it out. But I want to draw it out just to show you what's going on. We're going to have an x and y axis like we've got here. I'm going to do it quite big. Something like that. And what we're actually going down, aren't we? So I'm going to make it a little bit bigger going down. Okay, so we've got our x-axis and our y-axis. Just a sketch And now I'm going to add on our z-axis. Now we're going to have to try and imagine what's going on here. To show it's going into the page, I'm going to use a different coloured pen. This is going to be far away from you. It's going to come towards you, pass through the origin, and then keep coming towards you. Okay, so any time I've got something that's going into the page, I'm going to add it in a red pen. Okay, and this is going to be our z-axis. Right, so let's draw this out. We have 6 to the right, so it's going to go along 6. Let's say this is a 6 here. Okay, now we're going to go down 4. So I'm making this was 6 was parallel to your x-axis, this 4 is going to be parallel to your y-axis. And now we're going, make that z a bit clearer, we're going 3 in the positive z direction. So let's say positive z direction is going into the page, shall we? So I'm going to add a vector of 3, and I've done it in red because we're going into the page. Okay, so that was 6 positive x direction, 4 in the negative y direction, so 4 down, and 3 going into the page. So if we were to work out the magnitude of that vector, what we're in fact working out is from the origin to the end of all 3 of them vectors. So when we go along the 6, down 4, and across 3, where do we end up? We would end up here. So let me add that on. I'll do it in a solid straight line. And that there is the magnitude of this 3D vector. So you could draw that on as the magnitude of A. Now you could split this into 2 triangles, and it's going to be even harder to visualize, but it would work. You could do, look at this triangle in black. Okay, you've got a right angle here and a side and a side. So you use Pythagoras to work out this angle, and then you've got another right angle, and once you've worked this out, you've got 2 sides, and you can work out that last angle. You could work it out as 2 triangles. That would work. It's not the quickest way of doing it. The quickest way of doing it is just using Pythagoras, but you're adding an extra term. Okay, it works out as doing the same thing as well. So let's do that. We've got the magnitude of vector A is going to be equal to all of these parts. So you've got your 3, 4, and your 6 squared and added together. So we've got, let's have a look and relate it back to our original equation. We've got 6, putting it in brackets, squared, plus negative 4 in brackets, squared, plus 3 squared. I'm going to square root that. And what does that give us? Well, 36 plus, because that, when I square that becomes positive, plus, I'm going to square root all of that. Stick that into your calculator. Square root of 36 plus 16 plus 9. So you get root 61. Okay, and that is your magnitude of a 3D vector. So it's exactly the same process. I did this just so you can visualize what's going on, but really you can go straight from this to your calculation and work it out in one step.